Hello everyone. So today we're going to be looking at this topic called infinite limits. It's a calculus topic, particularly Calc 1. And today we're going to find the limit as x approaches 2 of 2x over x squared minus 4. Now, before we look at the behavior, we can look at some things that you typically look at in a pre-calc class. So if you factor the function 2x divided by x squared minus 4, you can factor it, the denominator as x minus 2x plus 2. So you have 2x over x minus 2 times x plus 2, okay? Now, with that function, if you recall, you'd have two vertical asymptotes, one at 2 and one at minus 2, okay? And if you were to look at the behavior of the graph near 2, you have that the function approaches infinity as you approach 2 from the right. So yeah, 2 from the right means you're approaching 2, but you're looking at numbers that are a little greater than 2 in so many words. Kind of a mundane way to say it. And if you're coming in from the left, you're going to negative infinity. Okay? So if I were to ask you, well, what's the limit as x approaches 2? I'd say it does not exist because there's not one uniform behavior, okay? So that's the answer. Now, obviously, we're not always going to be able to graph our functions here. So is there another way of doing this? There's a couple ways of finding these limits without graphing. So if you look at the limit as x approaches 2, 2x over x squared minus 4, if you start looking at this from an analytical point of view, the numerator approaches 4 and the denominator will approach 0 because as x approaches 2, the x squared approaches 4 minus 4, 0. So you have a number over 0. And the first mistake I see people say is, oh, well, you got something that's undefined and the answer is undefined. The answer to that is no. When we say 4 over 0 or any number over 0, what we're really saying is that the numerator approaches a number and the denominator approaches 0. I'm not saying it's 0, but it's approaching 0, okay? So that's why saying, oh, it does not exist, it's undefined, is not correct. Now, in general, this is what's going to occur. When you have a rational function of sorts, and when you take the limit and the limit approaches number over 0, and when I mean number over 0, by the way, I'm typically going to say not the number on the top, the numerator is not equal to 0. That's like an indeterminate form, that's something else. This typically involves a vertical asymptote, and the behavior is usually going to be infinity minus infinity or does not exist. Now, that all depends on a couple things. It depends on the behavior of your function and near that point, and the value of the function, whatever is given, okay? The direction as well. So how do I figure this out maybe without graphing? Well, a couple ways of doing this. The first thing I'm going to do is I'm going to look at the behavior near the right. So if you tell me the behavior at a number, you get number over 0, and you're approaching just the number, I'm going to look at from the left and the right. So as I approach 2 from the right, and also one other thing, I'm going to look at the factored form. And the reason we're looking at the factored form is usually that's a little easier to work with, okay, when working with these limits. But you don't have to factor. It's up to you to keep it as the denominator is x squared minus 4, but I'm keeping the denominator as x minus 2, x plus 2. Sorry, not keeping it, but factoring it. Now, one way to approach this is to arbitrarily approach 2 from the right, meaning that I'm going to plug in numbers that are close to 2. So 2.01, 2.001, 2.001. All my numbers are pretty close to 2, but they're a little larger because you're approaching it from the right. And as I go down my list here, these numbers, get closer to 2. And if you look at your y values, they get really large. And that's basically indicating that this is going to go to an infinity here, okay? And likewise, if you approach 2 from the left, you're looking at numbers that are a little smaller than 2, which we're plugging in. So 1.99, 1.999, 1.9999, and these are the values that you get. And these values keep getting smaller arbitrarily smaller, and then the answer to the limit would be minus infinity. So overall, I would say my answer for this question would be does not exist, because the limit is approaching two different things from from either direction here, okay? So does not exist. Now, some people say, yeah, but it doesn't seem very technical to me what you just did by plugging in values. So what you could do is something along these lines. Let's go back to limit as x approaches 2 from the right. And what I have here let me highlight this, and the little quotations here is saying, well, let's say we took this limit, and this limit right here approaches, what I'm saying, it's when I say equals, it's not equals in parentheses, in quotations, I'm sorry, is saying it sort of looks like 4 on the numerator and then 0 on the denominator. And I put a little plus there, and here's why. Because as you approach 2 from the right, x minus 2 is going to be positive. It's going to be really close to 0, okay? X plus 2 will be positive as well. But x minus 2, the key there is that it's really small, and it's positive though. Something really small and positive times 4 is going to be something positive. So if you have something that looks like 4 and you're dividing by something that's super small and positive, it gets really large. Likewise, if you do the same argument as what we just did right now, but you're coming in from the left, the numerator still looks like 4. 2 times 2, 4. And then the denominator, though, looks like 0 as well, but you are looking at small values close to 0, negative values. Because if you approach 2 from the left, the part where I have x minus 2, that's negative, and it's really small, like negative, some small negative number. So that's why we have the little negative here. So 4 over 0 with the negative there, it's like a positive over a negative. Yeah, this means close to 0, but it's negative. The top is 4, so you get a negative infinity. So both directions would just tell you that the limit doesn't exist. Okay. Now, as I said earlier, this limit all depends on, these limits all depend on the function, the behavior of your function near a point, etc. So let me first of all write our result again for what we just did, which was does not exist. And let's take a look at this function down here, which is the limit as x approaches 3 from the, let's say, yeah, right, for 12 over 3 minus x. Over here, 12x over 3 minus x, excuse me. The behavior for this would be, looks like 36 on the numerator, and how about the bottom? It looks like 0, but it's small negative numbers with that minus. Why? Because as you approach 3, and I'm sorry, that's really bad. I just noticed that. It looks like a combination of an arrow and 3. That's approaches 3, I'm sorry. That's going to be 3 minus 3.01, 3.01. It's negative. So 0, really close to 0, but negative numbers. So you have a positive over a negative. It's going to go to negative infinity. Okay. And again, because the top, the results, what we have, because the top looks like it's 36, and the numerator just gets really small, near 0, but it's negative. So you take those numbers, and yeah, you can see this yourself. You take 36 over minus 0.1, this would be like negative 360. 36 over negative 0.01, maybe negative 3600, etc. So that's why you get that behavior, okay? So thank you so much for your time, appreciate it. I hope this helps.